Right. Now there's one video on this exercise for you too. I'm going to start with the introduction. Let's refresh you about the unit vector I, j, and k. Now on I, j, and k, they are actually this is a unit vector in direction of x. Okay, and this is same, but in the direction of y, same unit vector in direction of z. And so we can represent the I in the form 1, 0, 0 as follow. Now just a quick mention that what is a unit vector. Unit vector is a vector which is magnitude is 1. So say if I say u is a unit vector, so if I find its modulus, it is equivalent to 1, right? Is that clear, right? And as you can see, the magnitude of I is definitely 1. If you find it, you can see it will be I square 1 square plus 0 square plus 0 square. And this is definitely equivalent to 1. And also we represent j in the component form 0, 1, 0, and k in component form 0, 0, 1. And so now let's look at just one example on this, so how to express the vector in ijk form or unit vector form. You think about it, we can write like this, space here, free, and of course I can factor the 2, so it's just a scalar, so it becomes 1, 0, 0. Okay. Using a similar line of thinking, you can also factor the 3 and you left with here. So this is 2i, right? And this is actually just j, and this is 3k. That's nice. Just a quick one on this. So 2, 0, negative 5 will be easily just you just write out. It's just 2i plus 0, 0j plus negative 5 times k. In other words, this is 2i minus 5k. I hope you're clear about that. And it's moving on to the fifth question 5. I just want to discuss about finding unit vector. The formula for unit vector, if you're given a u as this case, a, b, c, okay. So the unit vector, sometimes we represent the unit vector by putting a hat. Rather. By doing so, we calculate its magnitude, right, and find the reciprocal. This is the 1 divided by the magnitude of u, and we multiply that value by u, and then that will be your unit vector. This one is the unit vector. I'm going to show how we can find this. So suppose I let u. It's always easy to represent a vector, by symbol like this, because that way you can refer to it easily always. Anyway, the magnitude of u, you think it's 1 plus 2 square 4, and negative 3 square, that would be 9, and you end up with a square root of 14. And so a unit vector, this one you can do this, will be 1 over square root of 14, right? Just following the formula, times the vector u, and you will have you can leave it like that, that's fine, but it's always nice to do this. Negative 3, right? And if you want to be just go one step further, it is not really necessary, but I'll just show you. Then this is minus 3 over square root of 14 k. See, as you can see, this is how you find a unit vector. And the question is why we want to find a unit vector. What's the point? There's some application to this, finding unit vector, and show you. Now look at this question 7 in the same exercise. So find a vector that is in the direction of 2, 1, negative 1, 2, and is 6 units in length. That means this vector, okay, well, I'll let u be this vector 2, 1, negative 2. So that means there is a vector. Yes, we have u now. I actually not quite sure its magnitude, but you calculate it, it should be for it's 9, 3. You know, it's actually 3. We'll show that later. I can show it now. Okay. Its magnitude is 2 square plus 1 square plus negative 2 square, and this is 4 plus 1 plus 4, which is 9, and this is 3. And so this vector is 3 unit in length. It could be 3 meter, 3 cm, and what have you. So this is 3 units in length, and we want to now find another vector which is 6 units in length. One way you can do this is that, and this vector is actually in the direction of this, and if you sketch it out, you can actually just times 2, in fact. But we want to practice this method of finding a vector using unit vector to find another vector. So what we do is we find the unit vector u hat here, which is 1 unit now. And then when you times 6, you get a vector that is 6 times the length of u. Well, let's say call it a w, and w is actually the result of 6 times the unit vector u. Right? So 6 unit. And so this is what we're going to do. So we have this now, and so the unit vector this is of u is this times u. And it's actually 1 over 3, 1/3, and 2, 1, and 2. I'll leave it as follow. And so, so the said vector that we want to find will be equivalent to 6 times u, the unit vector of u in the direction of u actually, and that will be 6 times times 1 over 3 u, right? Okay, I just put it now rather. Okay, let's write this down, and that will be just 2, 2, 1, negative 2, or that will be 4, 2, negative 4, whichever you like. You can leave it as follow, or and end it like this. And so this is the vector we're talking about, 4 to negative 4. And what, so we'll go one step further. Let's go one step further and look at one other problem. We end this video with this problem about a variation of question 7. Look at this. A is a point 234, and B is 14 units from A in the direction of this. Find coordinates of B. This is a more challenging question. So what we do, but still, now what we do is first we find. We can start by this. We let u be this one. No, this is the direction of the vector that we're talking about. Let it be this one. And so we can then find this. I'll skip ahead and give you this square root of 49, you know, and 7. And so the direction vector, or sometimes you can now write unit vector. Sometimes they write this, right? AB. And never mind, we keep with this. I'll keep using this. So u vector heck is therefore what? This is 1 over 7. Now recall that this vector can be expressed in the component form. which is a nice way to represent a vector other than the ijk form. And you multiply this by this 1 over 7, and you end up with negative 3 over 7, 2 over 7, and 6 over 7, like the components. That's nice. And so what do we want now? Find the coordinates of B. So what we're talking about now is that the vector AB is actually 14. Okay, but if we try to use the definition of magnitude, is going to be not easy, as B could be anything that. So what we're going to do is we're going to form a vector like this. So imagine this is a point A. So this idea is difficult, so we use another idea. This B, the distance AB is 14. And so what we have done is that we know another vector which has the same direction as AB, that is this vector, and we have calculated its unit vector, which is probably here. Say this, and this is a U cap, right? Shorter, 1 unit. So this is 14 times in length. So if we all need to do this form AB. So AB is actually 14 times of U cap, isn't it? So 14 times this guy here, and you would end up with negative 6, 4, and 12. And so finally, what we want to find is imagine that A, B is here, and there's a reference point O, sometimes you call it origin, right? And this is vector A plus B. Oh yeah, sorry, this is vector AB, my bad. And so just use the idea of this triangle or vector to find OB. If you can find OB, then you know the coordinates of B. It's very simple. Clearly, OB is OA plus AB, right? This is from starting from O. You do not know OB, so you go from O to A and A to B, and hence you have this the sum addition of these two vectors. And you know what A is because this is 2, 3, 4, right? Just write down the coordinates of A. 2, 3, 4, given up top here, right here, plus AB, which we know what that is from here. And so the outcome is negative 4, 7, and 16. So therefore, the coordinates of B is minus 4, 7, and 16. You see, very powerful method, vector